Hello. Today we are going to calculate the strength and the efficiency of a joint. Now which joint? First of all we are considering the double cover single riveted butt joint. Here the thickness of the cover plate is taken as 6 mm each. The main plate is 10 mm thickness. The width of the plate is taken as 200 mm. 3 bolts of 20 mm diameter and with a pitch of 60 mm center to center. Edge distance is taken as 40 mm. So 60, 60, 120, 40, 40, 80. So the total width is 200 mm. Now, first of all we have to find out the design strength of a plate which we call the gross with a gross cross section, that is yielding. And when we are talking about the yielding, means there is no hole as such. And the formula is TDG is equal to AG into Fy upon gamma m naught. AG is the gross cross-sectional area, is nothing but the width of the plate into thickness of the plate without hole. That is 200 into 10 is value of AG. Fy is taken as 250 if not mentioned. Gamma m naught is taken as 1.1. This will give the result in Newton. Divided by 1000, it will give the result in kilo Newton, and it will be 454.5 kilo Newton. Now we will go for the design strength of a rupture that is critical. That is TDN. TDN is nothing but 0.9 AN Fu upon gamma m1. And of course, this result will be, of course, no doubt in a Newton. We will divide it lastly by 1000 to get it result in kilo Newton. Now AN is the net area. Net area is the total width minus 3 times D naught, because not D but D naught, that is the hole. If 20 mm diameter is there, means the diameter of the hole is 20 plus 2, that is 22. So 200 minus 3 times 22 into thickness of plate as 10 mm, that will give, divided by 1.25, and when divided by 1000 will give the result in kilo Newton for the critical section, and it comes out to be 395.5 kilo Newton. Now we will go for the next part, that is design shear strength of a bolt. The formula is very easy, already mentioned in the course so far, that VDSB is equal to VNSB upon gamma m naught, gamma m1. And VNSB is nothing but Fu upon under root 3 and N into ANB plus NS into ASB. When it is a butt joint, and N is equal to 1 and NS is equal to also 1. A and B is nothing but the area of a thread portion of a bolt, that is 0.78 times pi by 4d square. It comes out to be 245 mm square. And A and B is nothing but the area of a shank, that is pi by 420 square, and it comes out 314.1 mm square. Substituting the value for FUB upon under root 3 as FUB is 400 and whole is multiplied by 3 because we are calculating the strength for the whole section. So there are 3 bolts, so we are multiplying by 3. and divided by, as usual, we are finding the value, we are dividing by gamma m1 and divided by 1000. They are already taken into consideration, and the value comes out to be 309.89 kilonewton. Now we will go for the design bearing strength of a butt joint. Design bearing strength. Mathematical expression for the design of the bearing strength is VDPB upon gamma m1, and VDPB is nothing but 2.5 kb dt into Fu. Now, first of all, we have to find out this constant kb. Kb is equal to E upon 3 times d naught. E is given as 40, 3 times d naught. P upon 3 times d naught, 60 upon 3 times d naught minus 0.25, it comes out to be 0.65. This comes out to be 0.6. FUB upon FY, FUB upon FU, it is 400 upon 410.97, lastly one. We have to consider the least of the 4, so it will be 0.6. Substituting the value, and we can find out the VDPB is nothing but 2.5 kb coming from here d t fu into number of bolts 3 divided by gamma m1 and converted into kilonewton, it comes out to be 295.2 kilonewton. Now first of all, we have to see the strength of the joint. Strength of the joint is the least of the critical one, shearing 2, and bearing 3. So least is nothing but, least is 295.2, that will be the strength. That will be the strength of the joint. Strength of the joint is least of the 3, 295.2 kilo. Least of the 3. Efficiency. Efficiency nothing but the strength of a joint divided by, it has already mentioned over here, that is strength of a joint divided by strength of, yielding strength of a plate, means plate without hole. Plate without hole, that we have already calculated in the beginning like this, that is Ag Fy upon gamma m naught. It's 454.5. So the strength of the plate upon strength of an unyielding, that is gross strength, multiplied by 100, that is, this is the strength of a plate divided by 454, and it comes out to 60.95%. So this way we can find out the strength as well as efficiency of the joint. Now, one important thing that I just wanted to emphasize, while calculating the thickness, we have to compare the thickness of these cover plate, add the thickness of these two cover plate, and compare with thickness of the main plate. And then whichever is less is to be taken into consideration for the design or this, just to calculate the strength. Just for example, this is 6 mm, this is 6 mm. Total addition will be the total length, thickness of the cover plate is 12 mm, thickness of this is 10 mm, means this will be less than the thickness of the two cover plates, so we are considering 10 mm. If that would have been a 4 mm, then 4 plus 4, that is 8, compared with this, and whichever is less, so at that time we would have considered the value of T as 8 mm, not the 10 mm. This is the most important thing that is to be taken into consideration at all. Thank you very much.